you've been all over Google. You're now at Baidu. And Baidu recently had a paper out about image question answering. Tell us a little bit about that.
Yeah, sure. So both of the previous speakers, I guess Kevin and Alejandro, both mentioned the desire to go beyond just labeling stuff in images. And so our team at Baidu tried to do that and take it really, really far. So just last week, we announced a result in what we call image question answering, in which the problem is, given a picture and given a question about the picture, can you create a natural text answer about that to answer the question? So we might show the system a picture of a bus and ask, what's the color of the bus? And say, the bus is red. Or tougher one, show a picture with people and sheep on the grass field and ask, what is there on the grass except for the person? And the right answer is sheep. So some of these are surprising, are subtly difficult. And using deep learning, using LSTM to parse a question, using embedding to parse the image, and then using another LSTM to output the answer, we were actually able to do this, surprisingly well. I was excited about this because this is one of those areas that if you had told me 2 years ago we'd be able to do this today, 2 years ago I wouldn't have believed you. But our team, Wei Xu, working with an intern we have from UCLA, was able to get, I thought, stunning results in this very difficult problem.
So what do you think is the major application for this? What's the killer app to use for this?
Yeah, the honest answer is I don't know. One of the challenges of a lot of computer vision is that thanks mostly to deep learning, I think over the last couple of years, computer vision technology has taken off like crazy, right? We can all do things that most of us couldn't imagine doing 2 or 3 years ago. I think the technology has advanced so rapidly. We can caption images, answer questions about images, do all these fascinating things. Kevin showed all these interesting examples that I don't know that we've necessarily yet come up with the right killer apps today for the vision technology. On Baidu's image search, we use a bunch of this. We use face recognition. We use a bunch of these things, but I feel like there is an opportunity to create another future generation of products. Maybe weight loss, maybe something else, I don't know, that I don't think we have necessarily the right ideas yet.
So Baidu has been behind a push to get into using high-performance computing. Mm-hmm, yeah. How does that shape your research?
Yeah, so let's see. The basic ideas of deep learning, a lot of them have been around for decades. And so people often ask me, why is deep learning finally taking off now, or maybe in the last 2 or 3 or 4 years? And I think my answer to that is that there have been 2 things that we've been able to have access to only recently. One is the data, right? Now leading tech companies now have access to vast amounts of data to feed these algorithms. But the data has been around for a while. But the thing that we've really only gotten our hands on in the last very small number of years is the big iron, is the huge computers to process all this data. And I think 2 of the big drivers that's making deep learning really take off now is with the data and the computation. So at Baidu, we've been betting heavily on using HPC, or high-performance computers, also called supercomputers, as the way we scale out our deep learning algorithms. Most of you know that deep learning, right, the fundamental operations are very large linear algebra operations, and it turns out that HPC, supercomputers, are very well suited to these technology, to doing these sorts of computations at scale. So at Baidu, we've hired probably some of the best GPU hackers in the world, and we are building really supercomputers. And the team is doing, and when I say scaling up, sometimes people think, you just build a bigger machine, but it's actually really difficult. The HPC technology we're building to scale up deep learning algorithms is some of the hardest technology that I've personally been involved in working on. And we have very good GPU hackers. They're doing some pretty special, some pretty crazy complicated things with GPUs in order to scale up our algorithms.
And you yourself have been focusing on speech recognition.
Right.
So how does the move towards HPC computing, how does that change your work on speech recognition?
Yeah, so, I've been excited about speech recognition for some time. It's one of those technologies that has been around for decades, sort of, but I believe is on the cusp of taking off and transforming the way all of us interact with technology. So the whole world is moving to mobile devices, right? The whole world is moving to cell phones, and all of us spend so much time typing on these tiny little keyboards. I think if we can get speech to work, it will transform the way all of us interact with cell phones and with other pieces of technology. And I think most people don't understand the difference between 95% accurate speech recognition, which is maybe where we are now, depending on how clearly you speak and so on. Most people don't understand the difference between 95 and 99% accurate speech recognition. It's not just an incremental 4% improvement. I think 99% is a game changer. And as we make incremental gains from, let's say, 95 to 99% improvement, we'll all go from using it on very rare occasions to using it all the time and just not even thinking about it. If you think about it, imagine if your laptop's keyboard registered 95% of your keystrokes. I mean, that would drive you crazy, right? So I think this could be transformative for the way we interact with technology. To say a little bit about how we've been approaching the speech problem, almost all speech systems have converged to a sort of a traditional speech pipeline with a distinct, fairly well-defined set of modules. So you start off with the audio, compute MSCCs or spectrograms, then you try to figure out the phonemes, then you string them together to words of a language model. There's an HMM, there's search, and so there's like a standard speech pipeline which almost all production systems use today. So what we decided to do, what our team at Baidu decided to do, we said, let's take the whole thing and let's blow it away and replace it with a neural network. And by building that on HPC, together with a ton of data, most academic speech papers use maybe a couple thousand hours of data. We use 100,000 hours of data. But the combination of tons of data together with the HPC to process that data, that's allowing us to drive, I think, significant improvements in speech recognition performance. And we could not have done this work but for the close partnership between our machine learning team developing the network architectures and our computer systems team, which is doing the HPC work that allows us to scale up these models to process huge amounts of data.
Where are you getting the data from? I mean, it seems like a massive amount. Where are you getting it from?
Yeah, so let's see. So we collected ourselves. So we got 7,000 hours of data ourselves. So, that was a lot of effort, but we could do that. And then the other thing we did was use data synthesis in order to synthesize a large amount of data. So it turns out that if we record an audio clip of, say, Katherine saying something in a quiet environment like in this room, and if we were to record the background noise in a noisy coffee shop, because of the superposition principle of sound, which basically means adding, if you take the audio clip of Katherine speaking in the quiet environment and add it to the audio clip of a coffee shop, then you have what sounds really awfully similar to what Katherine would sound like if she was saying those same words in a noisy coffee shop. So by taking our original 7,000 hours of data and adding it to about 15 different types of noise per audio clip, we then multiplied our data set, went from 7,000 to about 100,000 hours of data, and that's what we ultimately trained our speech system on.
So you've got this variety of audio environments that you're training on, but are you working mainly in one language at this point, or are you trying a variety of languages?
Yeah, right. So, we had first done our work in English because our Silicon Valley, our California team is largely an English-speaking team. And because Baidu operates primarily in China, the second language that we're working hard on is Chinese. And it's been interesting. One of the nice things about working in multiple languages simultaneously is it kind of forces us to driving us to look at what the fundamentals of language rather than the things that are specific to any one language, such as English. And it turns out that there are a lot of things about Chinese that are challenging. So it turns out that English has 26 alphabets. Chinese has about 5,000 characters. And so that has caused us to have to rethink both how to architect our systems for scalability reasons, as well as how to deal with rare characters, right? Chinese characters are, let's say distributed Zipfian, and so some of those 5,000 characters we'll see only a very small handful of times in our training set. So how do you have a learning algorithm, learn to recognize a character that you've barely seen? So those are some of the challenges we are working to address to get this to work in Chinese as well.
Do you find that people use it when they're speaking English differently from when they're speaking Chinese? Are they more conversational or less descriptive in one language than another?
Yeah, that's an interesting question. Let's see. When we speak, when we do voice search, most of us naturally become more conversational. So we tend to, ask questions like, like, hi Baidu, hi search engine, help find me directions to the nearest coffee shop or whatever. Right? So we actually become more conversational. One unusual thing, one challenge and opportunity about operating in China specifically is that China is a developing economy. And so whereas probably most of us, maybe all of us in this room had cut our teeth on desktops and laptops, and then we're slowly migrating to cell phones and learning new behaviors on cell phones, China as a developing economy means that the majority of users, their first computational device, for a lot of users, their first computational device is a cell phone. And it's a challenge and an opportunity because they've never been trained in technology. Sometimes we even have illiterate users that don't know how to write. And if you don't know how to write, to do web searches, we pretty much have to provide a search interface. That's one of our motivations working on speech. So that's sort of the challenge. But the opportunity is also that we get to teach people how to use these devices from scratch without habits that all of us develop for laptops and desktops that to some extent maybe have to be unlearned.
It's really fascinating. What do you think the impact of great speech recognition is going to be on educational opportunities, especially in developing economies?
Yeah, I think that Baidu's mission is to connect people to information and also services. One of the things we really want to do is not just find information, do a web search, like there's a web page, off you go, bye. But we really want to figure out your needs and help fulfill your needs. So here's a specific example. If you search for a movie ticket, if you search for a movie ticket on the Baidu search engine, rather than saying, there's a website, off you go, have fun, we actually try to fulfill your need, which is to buy a movie ticket. So right there in the search engine, we allow you to not just buy a movie ticket, but actually select what seat you want in the movie theater.
So I want to change tacks a little bit, and I really feel like a lot of the public conversation around machine learning, in particular artificial intelligence, is about the threat that it poses to humanity when the killer robots are going to come and we all need to run for the hills. But you have a great quote that's going around Twitter, which I think is along the lines of, I don't worry about AI becoming evil the same way I don't worry about overpopulation on Mars. What do you think the machine learning community needs to do to make the public conversation about machine learning more realistic?
Yeah, so I guess many of you have seen, a few, Elon Musk and a few others talk about AI superintelligence and maybe things like evil killer robots. And I think, as Katherine said, I think that I don't want to dismiss that entirely. Maybe hundreds of years from now, if someone invents a new technology that I haven't seen yet, anything could happen, right? But the reason I don't spend my time trying to prevent AI from turning evil is the same as the reason that I don't spend my time trying to combat overpopulation on Mars. And, you might say, but Andrew, someday we're going to colonize Mars and there's going to be overpopulation and there are all these children dying of pollution on Mars. How can you be so heartless as to not care about them? And my answer is, we haven't even set foot on the planet yet. I just don't know how to productively work on that problem. And so I feel similarly about the evil, killer robot issue for AI. And I find that most of us that are on the front lines building shipping code to users. I personally don't see a realistic path for AI to become sentient. AI is becoming much more intelligent. That's a great thing. But that doesn't mean AI is becoming more sentient. Maybe there'll be some future technology that makes it sentient, but I don't see a realistic path for that right now. And about Katherine's point about the conversation around AI, there are a few techno-utopians that think that technology will just make everything better all the time. Obviously, I think technology is a net force for the good. Otherwise, I wouldn't be working so hard on it. But I'm not as much a techno-utopian as others. I think that AI does pose one challenge to our society. Maybe not just AI, but technology broadly, which is a challenge to labor. For hundreds of years, the rise of technology, not just AI, but technology, has risked displacing labor. And I think the challenge we face now is that as technology automates more and more, we risk there being jobs displaced. And the difference compared to the early iterations is that it's happening much faster this time. So whereas the United States this country took maybe a couple hundred years to shift from primarily agriculture to manufacturing and then services. But that took a couple hundred years, and so our educational system could train the descendants of farmers to start farming as the tractors came in and automated farming, but we could train the descendants of farmers to work in manufacturing or to work in services. I think the real challenge that we might face today is that the transformation of the economy is happening much faster this time. So it's not so much about training the descendants of the truck drivers, but if self-driving cars automates away truck driving, then it might be people that are alive today, like the truck driver, that we need to reskill, retrain for a different job. And historically, our educational system hasn't always been great at that. So I think that is a challenge that I think, leaders in machine learning, in academia and government and in industry should have a serious conversation about, rather than the hype, I guess, about evil killer robots.
So what do you feel like is going to fill that gap, is going to help make education more distributed? Things like Coursera? Yeah,
I think that in order for people to keep finding meaningful work, I think things like MOOCs, Coursera, and things like Coursera, Khan Academy, lynda.com maybe, these scalable forms of education, they feel like our best shot to me right now. But even then, I think it will be challenging, and there's still work ahead, for Coursera and for these other organizations.
So also in terms of career advice, you did an AMA on Reddit recently, and a lot of people asked you for career advice. So what do you say to people who want to get into machine learning or are interested in exploring that?
Yeah, so I think, as Catherine said, did Reddit Ask Me Anything a while ago, and I was surprised how many people are asking for career advice on machine learning or other things. So let me share my thoughts on that. To those of you that want to develop your career, right, and enhance your own career, one of the things I've learned, working at Coursera and at Baidu, where we really obsess about employee development, is that developing yourself, learning new things or studying, right, it has almost no short-term rewards. So if you spend next Saturday staying at home, reading research papers, coding up things you find in papers, and then experimenting and learning, there won't be anyone to pat you on your back. And when you show up for work the following Monday, chances are your entire day spent studying on Saturday, it probably doesn't make you that much better at your job the following Monday. So investing in yourself, learning, has very few short-term rewards. But here's the trick, which is that if you study hard, if you learn things not just for one weekend, but you do it every single weekend for a year, then you will learn a lot, right? And so I think the long-term rewards for developing yourself are profound, but the short-term rewards are, almost non-existent. And one of the problems is that we as humans, all of us, tend to be much better at optimizing for the short term than for the long term or for the very long term. And I think the ROI, return on investment, for your spending time studying and learning is huge. It's extremely worth doing. And the challenge is maybe getting ourselves to do those things.
Let's open it up to questions.
Thanks a lot.
No problem. Do we have time for questions?
I think we have plenty of time.
Okay, great.
Yeah,
Excellent.
cool. Questions? Yes.
So
Hey, Christian.
I have a few kids, and I just wonder, what do you think they should study so that they are future-proof in 10, 15 years?
Yeah, I don't know. It's a great question. By the way, some of you know, Christian, I guess you've probably heard Christian's talk earlier this morning. Christian and I worked briefly together when I was at Google, and I found his image classification work very inspiring. Yeah, so those of you kids, what should they study? I don't know. I put thought into this. I think that one of the things I would love my own kids to have, if I have kids in the future, I don't yet, is for them to always be able to keep learning. I think that, the jobs that computers seem to be great at automating away are routine, repetitive jobs, right? The jobs where you kind of do the same thing every day. And this can be high skill or low skill, so things like self-driving cars. We might figure that out in the next decade or two, I think. But also things like, reading medical images. There are some very high skill radiologists whose jobs computers are also attempting to encroach on. So it's not just the skill level or the amount of training. It's more about whether the work you do is routine or non-routine, I think. And actually, here's one of my beliefs, which is that I think creativity can be taught. I think creativity and the ability to indent new things is not this magical thing that only a few really special people like Steve Jobs can have. I think being able to innovate strategically, to be creative systematically, there are processes to be creative that can be taught. And I think that one of the best ways to future-proof ourselves and our children is to teach them to keep learning and to teach them to creative and teach them to invent new things that seems very hard for computers to do today. Not sure that's a great answer, but it's my best one right now.
Hi. Can I add to that one and ask you about what do you think about the future in music and art, because you talked about creativity?
I see. Yeah, it's a great question. So I think one of the things I've seen is that computers are starting to be able to do things that feel creative. Actually, here's an example. Take chess-playing computers, right? Deep Blue. Once upon a time, we thought there'll always be purely mechanical machines, but as chess-playing programs became more and more sophisticated, right? Deep Blue and so on, the sheer muscle that they could put into computing chess moves started to allow computers to make moves that humans thought were surprisingly subtle and really deeply insightful. And I think what happened in chess was computers became so advanced at figuring out what chess moves to make that humans could no longer really understand how the computers were doing it. And when computers sort of pass the threshold that we can easily figure out how they do it, sometimes that's when it starts to feel like it's starting to become creative. I think in the short term, we're still some distance away from computers understanding music and be able to compose music at a level that humans can. But it's not obvious to me that will be out of the reach for forever. I think composed music are further along than, say, computers writing novels. Computers writing novels seems really far away, but computers composing music is, surprisingly getting better at a surprisingly rapid clip. Let me share you one other thing I'm actually passionate about. So, my family, I guess my mother actually runs the Hong Kong Arts Festival, right? And my father's a doctor. But my family has always been sort of half arts and half technical. And I think technology is great for teaching us about the world and teaching us how to influence the world. But maybe it's an unusual thing for a technologist to say, I really value the humanities as well. I think they teach us maybe not so much about the world, but they teach us about ourselves and our interactions with other people. And one of the things that saddens me is that a lot of the traditional arts, economic model is not working. A few months ago, my wife and I went to attend a violin concert by one of the top violinists in the country, according to these rankings or whatever. And I think my wife and I were the only two people in the audience that was between the age of 10 and 60, right? And I think that the arts hasn't scaled, and this is proving to be challenging for the long tail of artists. So one of the things I'm sort of passionate about on a personal level, maybe that more personal than professional level right now, is to try to find ways for technology to help these artists find a model that scales better, because I think they're important. Not sure that was what you're asking, but it's actually one of the topics I'm passionate about. I guess.
So one thing I'm wondering is, we've heard lots of times about the surprise that people have had. The surprise about, for instance, the image analysis and understanding, how we've gone from not really being able to do anything except build little features and try them together. And suddenly we can build these systems that learn what an arm is and what pixel should be what. And yet, on the other hand, you're saying you feel like the Singularity or deep AI or whatever is many hundreds of years out from now. How do you reconcile the fact that we don't manage to predict a couple of years in the future with your belief that these high technologies of thinking machines are so far away?
Yeah, the future is uncertain, and the further you try to peer into the future, the more uncertain you become. But I think with this attitude that anything could happen in the future, including, so many things could happen in the future that I don't see a lot of evidence for focusing on particular disaster scenarios right now. And I think the singularity could happen, in the distant future, much more likely than in the near future, in my opinion. But I don't see any way to productively work on it right now. And I think it is a distraction from the much more serious issue of the challenge to labor. And I think it's sometimes tempting, right? I mean, battery technology is improving exponentially. So does that mean that, pretty soon this will be as powerful as a nuclear bomb, right? And is that a risk? I mean, so you can extrapolate all sorts of things in the future, but I find the arguments for worrying about the singularity in the short term, the anything could happen, so let's worry about this, I found that less compelling so far.
Speaking of the future, if you were to look at the next 5 years, what do you think are the major technical directions in deep learning? Is it going to be, reinforcement learning or probabilistic models? Sort of what are the technical directions?
Boy, I wish I knew. Let me just tell you some of the things I'm excited about. One of the for many years now, the most reliable way to get better machine learning performance is bigger data, more data, more computation. One of the analogies I've sometimes made to the rise of deep learning is I think of building deep learning systems or building machine learning systems as a little bit like building a rocket ship, right? So how do you build a rocket ship? Well, a space rocket, is basically a huge engine together with a ton of fuel. And you need both to be big. If you have a ton of fuel and a tiny engine, you won't even lift off. If you have a huge engine, a tiny amount of fuel, you won't go very far, probably won't make it to orbit. And to build a space rocket, you really need a huge engine together with a lot of fuel. So the analogy to machine learning is that the fuel is our data, right? The digitization of a society, as more and more of our activities are in the digital realm, that creates data. So leading tech companies like Baidu and many others have a lot of data. So that's the rocket fuel. And the rocket engine are the huge computers, the big iron, like the HPC supercomputers in our case, but other computers that we can build to absorb this rocket fuel that we have access to. So that's been a pretty reliable crank so far. Bigger rocket engines, more rocket fuel means our rockets can go further. So I think that's one direction that I'm sure will keep improving. One more that's a bit more speculative that I'm excited about as an academic and an intellectual, but the payoffs will be harder to get is unlabeled data. So I think that many of us have gone to extraordinary lengths to get huge amounts of labeled data. So, for example, for the image question answering thing, we hired people to, I think we had about 100,000 images and 250,000 image and answer pairs in order to do sort of end-to-end deep learning, in order to give it a question, give it a picture, and try to learn to predict with a RNN, actually an LSTM, what is the answer. So that was labeled data. I think that there's a big opportunity, big untapped opportunity to use unlabeled data, but that none of us really yet know what are the right algorithms. So I'd love to figure out the algorithms for that, and I think there could be a big breakthrough there if we figure out what are the right algorithms.